Let's talk about bounds and error intervals. So this is a grade 7 GCSE topic and it appears in almost every single GCSE Maths paper. So it's quite an important topic. So if this is your first time, let's try to understand bounds. So say if a number rounded to the nearest 10 is 100, we want to find the range of the possible value of the original number. So I've listed out a few kind of integers that's around 100. So let's look at them one by one. Round to the nearest 100, that means you are going to look at the kind of units digit or the ones digit. So here's 4, that means you need to round it down, and that will give you 90, so that doesn't give you 100. But if it's 95, that does round up to give you 100, so this one does. And for the same reason, 96, 97, 98, 99, 100 does. And also for 101. Here, if you cut off over here, 1 is less than 5, so you round it down to 100. So this would give you 100 as well, 102, 103, and 104. But for 105, it would round up to 110. Okay, so let's write it down, 110, and this one will be round down to 90. So now, what is bounds? So bounds are like the boundaries where it can be round to 100. Let's look at the boundary. The lower bound, which is over here, is what we call the smallest number that can round up to 100 or to what you want. So we know for any number that's greater than or equal to 95, we'll be able to round up to 100. Okay, but if it's less than that, for example, 94 or even 94.9, still, when you look at it, you have to round up. So 95 is the smallest number that can give you 100. And then for the largest number, on this number line, you might think it's 104, right? But it's not necessarily integers. So actually, for example, 104.9999, it would also round down to 100. So actually, the largest number you can take is this. But because it's quite hard to write, so what we take as the upper bound will be the number that can round up to the next value, which is 105. But because we cannot take that value, because that value will give us 110. So what we do is that we put less than sign. We don't put less than or equal to, just less than, and then 105. Okay, in this case, we have indicated that the largest number you can take is 104.9 recurring, but keeping the value both like integers, not decimals. Okay, so this is just one example to understand how things works. But in definition, the lower bound is basically the smallest value that would round up to the estimated value, while the upper bound is also the smallest value, but that can round up to the next estimated value. Okay, for example, the lower bound in this case will be 95 because that's the smallest number that can round up to 100. While the upper bound is 105 because that's the smallest number that gives you the next estimated value, which is 110. But we take the smallest value, but not the largest one, but we take anything that's less than that. Okay, hope it makes sense. And now for the error intervals, it's just like what can give you the estimated value. And we usually write it as an inequality like this, where the value, usually a letter, is greater than or equal to the lower bound, but only less than the upper bound. Okay, we use LB or UB to represent lower bound and upper bound. So there are two kinds of questions. One is about the error interval of a rounded number. The other is about a truncated number. So we'll talk about them separately. For rounded number, the key to remember is called half up, half down. So here's how we do it. For example, if you have 63.8, it's being rounded to one decimal place. We want to work out the upper bound, lower bound, and the error interval of the value. So the first step is that you would half the size of the interval. You might wonder, what is that? So basically, if it's being rounded to one decimal place, the interval, let's say 1 dp, the interval will be 0.1 because that's where you look at the cutoff point. That's the interval. Okay, and then if it's 2 decimal places, then it's 0.01. Okay, and if, for example, it's to the nearest 10, then the interval is just 10. And if it's to the nearest 100, it's just 100. If it's to the nearest, for example, whole, that would just be 1. Okay. Anyway, over here, the interval or the degree of accuracy is 1 decimal place. So that is 0.1. So your first step is to halve it. So if you halve it, that will give you 0.05. Okay, this is very important because you're going to use that a lot. So now what you do to get the lower bound is that you use the number 63.8 to take away that half. And that will give you 63.75. And this is the smallest number that can round up to this number. Let's check. Okay, so if you cut off over here, this can indeed round up to give you 8, and that is the smallest one you can take. Okay, and then for the upper bound, we can do the number itself again, the rounded number, add half the interval, and that will give you 63.85. Okay, so that's how you get the lower bound and the upper bound. But do pay attention that for the error interval, you can only take the lower bound, but not the upper bound. So it will be, we usually use x is greater than or equal to the lower bound and less than the upper bound. Okay, so that's the whole question. Now let's go back to the initial example and see if it works. So over here is round to the nearest 10. So the degree of accuracy is 10. So if you do want to find this out instead of listing all the numbers, is that you first half the 10, write it as 5. And then to get the lower bound, you do 100 take away 5, which is 95. To get the upper bound, that is 100 plus 5, that's 105. And lastly, if you want to write it as inequality, you do x is greater than or equal to 95 less than 105, which is exactly what we had here. Okay, hope it makes sense. Now let's just try to practice. I've prepared everyone a question. You can pause the video, have a try, and we'll talk about it. Okay, so here I have a number a is rounded to 1 decimal place, and we have 10.0. Okay, complete the error interval for a. So if we follow the steps, half up, half down, we first find that half. To 1 decimal place means the degree of accuracy is 0.1. So you do a half times 0.1, that's 0.05. And now you do half down to get the lower bound. So you do 10.0, take away 0.05, that gives us 9.95. Okay, double check. So if it's 1 decimal place, here you round it up and make it 10, and then make it 10. Okay, very good. Then we can, try the upper bound. Upper bound would be the rounded number at half the unit or the degree of accuracy. That's 10.05. And double check, that is the largest number that can round up to the smallest number that can round up to the next value. Okay, for the error interval, you can just put a in this case. And then that will be greater than or equal to 9.95 and less than 10.05. Okay, so that's this question. Now let's look at a slightly trickier question. So for this one, you can also pause the video, have a try, and we'll talk about it. Okay, so here, Tom travels a distance of 100 miles, correct to the nearest 5 miles. Work out the error interval of the distance that Tom travels. Okay, so it's 5. It's a little bit weird, but you do the same thing. You half the degree of accuracy is 5 miles. So you half that 5. Then you will get 2.5. And then to get the lower bound, you just do 100, take away 2.5, which is 97.5. And for the upper bound, you just do 100 plus 2.5, and that's 102.5. For the last step, you put it as x as an inequality. So x is greater than or equal to 97.5 and less than 102.5. Okay, so that's how we do it.